so on Thursday, like I said, we're gonna have a test, and that test is going to include what's listed there on the board. You'll have to classify matter. Is it a colloid, suspension, solution, solute, solvent, element, compound. You'll have to identify intensive versus extensive property. You'll have to identify is it a chemical change or a physical change. Number 4, chemical property or physical property. And then the last two, number 5 and 6, we're going to cover today. Define specific heat, which you should have a little bit of familiarity from freshman year, and calculate the final temperature of a system. Yep. Yeah.
Okay.
So, like I said, if you're gone, I upload these on YouTube so you can watch it. The homework is right there. Okay? Do tomorrow. Yep.
Is this, it's kind of gonna be like the sheet we got, a lot of same stuff?
We're going to do some reviewing on Tuesday and Wednesday, but yeah, I would say it's like the sheet you got. Well, it's not going to be matching, it'll be multiple choice. But I'm going to give you another worksheet tomorrow
Okay.
that will be
A lot like
a lot like the test, except I think the substances that you're going to classify are a lot clearer. Because the worksheet is pretty good, but they give you a few weird substances to
Yeah.
classify, like things that you wouldn't be familiar with, like India ink. Yeah, I don't think any of you, it's a colloid, but I mean, how would you know that? You know, so that's why when it comes to colloids, there's only 4 of them that are going to be on the test. Jello, milk and water, clay and water, dust and air. Those are the 4 colloids that you are familiar with that I would expect you to be able to classify. But the test will be multiple choice, some short answer, and then a couple math problems. It's actually fairly short. So I'd say it's 1 page both sides. Yeah, it's about right. So, any other questions about the test on Thursday?
Are there gonna be any like 1 or 2 experimental things?
Unit analysis?
Yeah.
Not specifically, no. But you know, we're going to use unit analysis the rest of the year.
Yeah, okay.
So, any other questions?
When do we get our labs back?
I graded them. I got to put them in the computer. You'll get them back. You should get them back tomorrow. Now, probably not 3rd and 4th and 7th hour. I'm still working my way through those, but I got first hour done. So you guys are lucky in that aspect. Alex?
So what kind of problems are going to be on it again?
Multiple choice, some short answer, and like 3 math problems. Any others? All right, so let's define specific heat. This is the last topic in chapter 3.
What?
So specific heat is the energy it takes
Specific, it's
not even close. And those of you who like objectives, our objective today is to define specific heat and be able to calculate the final temperature of the system. Specific heat is the energy it takes to raise the temperature of a substance to raise the temperature of 1 gram of a substance, sorry, of 1 gram of a substance by 1 degree Celsius. And this information is straight out of the book. So this is, you know, one of those situations where you could just read the book and teach it to yourself. Yep, Jared.
So is it like in calories
Yes, you can, well, not quite. Calorie is a measure of energy, but you can use specific heat to calculate calories. So the specific heat of water, and this is the symbol for specific heat. Why don't we use S? Because S is sulfur and S is seconds. So C subscript P stands for specific heat. And the specific heat of water is 4.184 joules per gram per degree Celsius. And I should put, this is for water, because every substance has its own specific heat. Yep, Jared.
Isn't C what, carbon?
But C subscript P is not carbon. So that's why it's not just C.
What's S subscript P?
There is no S subscript P. So why IUPAC chose C, I can't tell you. Why did they pick S? I can't tell you. But it's C subscript P is the official symbol for specific heat, not S. Any other questions? IUPAC is the International Union of Pure and Applied Chemistry. They are the governing body that sets all the rules for chemistry. So when you become a super chemist, Brett, then you can join IUPAC. It's the coolest of the cool. Only the cool chemists are allowed in. So, all right. So that's specific heat. Now, what does that mean? So, if I have 1 gram of water, and I add 4.184 joules of energy, the temperature will go up by 1 degree. So if I have 1 gram of water and I add 4.184 joules of energy to it, the temperature will go up by 1 degree Celsius. And if I start going too fast, just tell me to slow down, because I'm kind of excited here, Mark. I want to get through all the stuff. It's great stuff, and sometimes I get so excited that I forget that you're learning it for the first time. So, if I have 1 gram of water at 20 degrees Celsius, and I add 4.184 joules, what's the final temp?
21 degrees Celsius.
So I got 1 gram of water here, Chloe, at 20 degrees Celsius. I add that much energy. What's the final temp going to be? 21. Okay, it went up by 1. Now, what if my initial temperature was 35 degrees Celsius? And I add 4.184 joules. What's the final temperature going to be there, Gruber? 36. So this number, the specific heat, is just the energy it takes to raise the temp by 1 degree. So what are the things that affect the temperature? Well, the mass. I'm going to put that on top. mass has an effect, right?
Wait, what's Q?
We'll get to Q. Just gonna get out blank. So the mass has an effect, right? The more mass, the more energy it's going to take to raise the temperature. The amount of heat you add, and that's Q.
It's like T5. TF.
TF. So the heat, the mass, and then your final temperature, your initial temperature, and your specific heat. So all of these are combined into that equation. So the temperature change is going to depend on the heat you add, the mass, your specific heat, all combined into that equation. Another way you can write this is anytime you have a difference. Anytime you have a difference, Joe, that's delta. So Q is equal to M delta T Cp. And delta T is always the final minus the initial. Okay? In science, if they say, well, take the delta, they mean take the difference, John. Okay? And it's always final minus initial. Always. Do not be led astray by others who say, well, sometimes it can be initial minus final. No, it can't. Okay? Do not listen to false prophets. It is always final minus initial. That's the official definition of delta. Okay? Not initial minus final. So, heat is in joules. Mass must be in grams. Temperature must be in Celsius. And specific heat is always joules, well, I shouldn't say always, but in science it's joules over grams degrees Celsius. If you are dealing with food science, you can work in calories. But in science, specific heat is in joules, because joules is the official measurement of energy.
Wait, what is T initial, T final?
The temperature. I'm just saying they must be measured in Celsius. We're not going to use
Oh,
the F
okay.
word in here.
Okay,
Fahrenheit,
yeah, I guess.
right? Don't use that word in here. Don't use any of those four-letter words like yard, foot. Use five-letter words: meter, liter, gram. So, mass in grams, Q in joules, temperature in Celsius, specific heat is joules per gram degree Celsius. Okay? So let's start with an easy one, Anna. Let's do, how about, I'll just make one up. Sort of. Okay, maybe I'm not gonna make it. Number 43 at the end of the chapter. If you want to follow along, you can turn to it. Otherwise, I'll just read it for you. Heated bricks or blocks of iron were long used ago to warm beds. Believe it or not, they'd have this big pan, they'd stick hot bricks in there, stick it in to your bed to warm it up so that in the wintertime it wouldn't be all cold when you stepped into it. Or you could hire an official bed warmer, someone who would actually sit and lie in your bed and use their own body heat to warm it up. That was usually for the kings and queens. You have a bed warmer. Your job, Ryan, would be just hop in their bed, warm it up, and then hop out.
It's amazing.
It's awesome.
I know. But you can use heated bricks or blocks of iron. And so it says 1.49 kilogram block of iron heated to 155 Celsius would release how much energy as it cooled